Okay, so we're talking about the multiplication. A over B times C over D is AC over BD. All right? Now, when we talked addition and subtraction, we said that our denominators were the same, so we left them alone. And multiplication, we're going to multiply straight across. So the numerators multiply the numerators, the denominators multiply the denominators. All right? So, 1/3 times 2/5 is equal to 1 times 2, 3 times 5, which is our 2 over 15. Right? Real easy. We multiply straight across. Okay? All right, now, with the same concept of AB, CD, A times B over C times D is really A over C times B over D, right? Okay, so now let's think about this. 9 over 15. Well, I know that 9 is not prime, 15 is not prime, so I could break these down to factors. Well, I know that 9 is really 3 times 3. So everybody with me on that? And 15 is really 3 times 5, right? Okay, now at the same token, this, if I take, here's my AB, this is my CD section, all right? So now I'm going to break this up into my AC and my BD. So this becomes 3 over 3 times 3 over 5, right? Well, anything over itself is what?
1.
1, right? We said that. So this is 1 times 3 over 5. 1 times anything is itself, so we're left with 3 over 5, right? So the idea behind this is we're breaking this down, and I don't really expect anybody to go through and write it in this capacity. What I'm guessing is what's going to happen is you're going to do something like this. 3 times 3, 5 times 3, right? And essentially what you're doing is when you're reducing this, you're not canceling. People say, oh, you cancel the 3's. You're not canceling the 3's. They don't go away. They don't go to 0. We're reducing them. We're reducing the 3's to 1 because this 3 over the 3 is a 1. Well, this 3 over the 3 is the 1. And you say to me, hold on, Edwards, what defeats he? Why is this 3 and 5 and that's 5 and 3? You jacked your problem up. Freaking write them down right. Doesn't matter. Because multiplication is commutative, which means that the order doesn't matter. 3 times 5 is 15, just like 5 times 3 is 15. So just like I reduced this to 1 here, this and this will reduce to 1, right? So we know that 3 times my 1 is 3. 5 times my 1 is 5. So I still end up with my 3/5. Is everybody with me on that? All right? So we're going to extend on this just a little bit. With this same concept, if I was to go ahead and I was going to start off and say, three over 5 times 1 over 3, right? I know that 3 times 1 is equal to 3. 5 times 3 is equal to 15, right? But I know that these are multiples of each other, so I'm like, well, I need to break this down. I need to reduce this. Don't wait till you get here to reduce. Start the reduction in here. Can I reduce upsy downsies, right? I can't do any vertical reduction. 3 and 5 don't reduce. 1 and 3 don't reduce. But if I think about it, I said multiplication is commutative, right? So the order doesn't really matter. So I can also think of this as 3 over 3 times 1 over 5, right? Well, this 3 and this 3 reduce to 1. Does everybody see that? That goes to 1, that goes to 1/5. So I know that I'm dealing with 1/5, right? Now you can physically change this up on, my numerators or my denominators, whichever one you want to switch. You can physically change them up just like I did. Or you can understand conceptually that they switch up. So instead of looking at it as when I have multiplication, and remember this is a multiplication thing, I can look up and down vertically to reduce, but I can also look diagonally. And that's why I know this 3 reduces to 1, this 3 reduces to 1. So 1 times 1 is 1. 5 times 1 is 5. Notice I still get my 1/5, right? So as long as we're multiplying, we can reduce up and down. Well, we can reduce up and down anyway, right? But when we're multiplying, we can also reduce our diagonals because because of commutativity, we can go ahead and rewrite the problem as such to work for us. Is everybody with me on that? All right? Okay. So at the same token, if I have 4/3 times 12 over 3 times 9 over 2, right? As I'm looking, this is all multiplication. So I go through, does this reduce? No. Does this reduce? Absolutely. So we're going to rewrite this. 4/3 times, this goes to 4, this goes to 1. Is everybody with me on that? Right? Over 9/2. Does that reduce? Now as I'm looking at this diagonally, well these don't match up here. But if I look here, this 4 and 2 will reduce out. So this 4, I'm going to divide both of them by 2. I divide 4 by 2, I get 2. I divide 2 by 2, I get 1. This 3, I divide this 3 by 3, I get 1. I divide the 9 by 3, and I get 3. Right? So now I'm at 4 times 2 times 3. And I know 4 times 2 is 8. 8 times 3 is 24, at least the last time I checked. 1 times 1 times 1. 1, which is our 24. Right? That's a lot easier than going 4 times 12 times 9 divided by 3 times 3 times 2. We don't want to do that. With reduction, it's best to go ahead and reduce early on. At least in my experience. I like to keep my numbers low. I don't like to rely on the calculator. Right? All right. How am I doing on time?
You're at 4 minutes, 30 seconds.
All right. Okay.